which carboxylate is the strongest base of these options? So let's think about basicity. Well, the weaker the conjugate acid, the stronger the base. The stronger the conjugate acid, the weaker the base. Also, the more stable the base is, the weaker that base is. The more unstable the base is, the stronger that base is, right? So we think about this. Acid, equilibrium, right? The more stable this guy is, the further to this side equilibrium lies, and the less able this guy is to pick up a protein. The more, proton, not protein, right? Not biochemistry here, organic. Okay, so the more unstable this is, the more equilibrium lies to this side, the more this guy is going to pick up a proton, right? So the stronger this base is, right? And so the weaker the conjugate acid, right? That means this guy, this conjugate acid is weak, so it's less likely to drop off a proton. So more of this guy is going to exist in solution. Weaker conjugate acid, stronger base. Stronger conjugate acid, the more this side of the equation is going to drop off the proton, right? Meaning on this side of the equation there's going to be more A minus in there. So weaker base for a stronger conjugate acid. Okay, so right now all these bases, what we're dealing with is we're looking at the base. We want to see how stable it is, right? Okay, so we have a minus charge on all these O's, okay, and we have electronegative groups on these three carboxylates, right? So that is inductive electron withdrawal, and this seems to be involved in a lot of these problems they're asking in the study guide. So inductive electron withdrawal, let's see, it increases acidity, decreases pKa, so that would make the conjugate bases of things with inductive electron withdrawal weaker bases, right? Because inductive electron withdrawal makes stronger acid, makes for stronger acid. So these Cl's make this a strong acid, right? So its conjugate base then is weaker, right? So there is no inductive electron withdrawal going on in this one. So A will be our answer, right? So we can compare for fun B, C, and D, right? So all these guys do is they pull electron density away from that minus on the O, right? And so that stabilizes it. That stabilizes the conjugate, this base, makes it less likely to go back over here, pick up a proton. So this guy has two electronegative groups right by the carbon, so that would be the weakest base. We can number these. This is strongest, this is weakest. So this guy is closer to the O, so that increases the acidity of the conjugate acid. The closer it is to that proton that could be dropped off, so it makes this a stronger acid than this, so it makes its conjugate base weaker. So that's number 3. This one's further away, so number 2. Okay, but in the end it only asks, or we could have stopped a little bit ago and gone with it.